Hi, today I'm gonna present this paper, Bacterial Growth Monitoring in a Microfluidic Device by Confocal Reflection Microscopy. A microfluidic device is denominated on a chip. It is a liquid handling device that focuses on controlling tiny quantities of liquids to allow chemicals, assays to be integrated on a small chip. The advantage of this kind of device is that reduce the consumption of reagents and sample solution, has a short analysis time, is easily automated, and has a low cost. These are all the advantages for replace the conventional techniques for analysis. The objective of this study is analyze the utility of confocal reflection microscopy, denominated CRM, in continuously monitoring planktonic bacterial growth in a microfluidic device. The confocal reflection microscopy is a variation of reflection microscopy that employs a confocal laser scanning microscope, which allows for the visualization of cell distributing in three-dimensional space. In this case, for this study, they use this bacteria, P. aeruginosa, that was grown in a LV medium. In this case, they study the test, the accuracy of biomass quantification by confocal image, and they use this software, assays, for analyze this image. Here in the microfluidic device using this study is a culture system consisting of a culture chamber. The volume in turn, it has 2 microliter, and the material of this microfluidic device is polydimethylsiloxane, PDMs. They, in this case, observe the planktonic growth by these bacteria in a microfluidic device by a microscopy, confocal microscopy, in a time course. Here we can observe the design of the microchip that they use. It has in the center of this a culture chamber, and it has a PDMS, and in the back it is a glass, and in this part only it will grow the cells. We have one inlet, one outlet, and the technique that they use for observe is here is the confocal microscope. They inoculate in this case by plug handling technique. So here they observe the planktonic growth of P. aeruginosa in a microfluidic device in a time course. Here we can observe they inoculate in different cell concentration, and they calculate the biomass with a three-dimensional image by CRM. So they observe that the biomass increase, and it is more in the cell concentration. The result of the number of planktonic cells increased with the time until 9 hours after inoculation, and after this time, no change was observed. For this, they conclude that the growth in a microfluidic device could be correctly visualized with CRM and could be measured with the three-dimensional image analysis based on CRM. Another thing that is important, that this method is for studying the ecology of microorganisms for which transformation methods are difficult to establish work. So here we can observe inside the microfluidic device in the design. They study how it is the better growing of the cell in the different hours. So in 0 hours, they don't observe any growth of the bacteria. In 3 hours, they observe a minimum growing of bacteria. In 6 hours, they observe its important growing of cells. By when it is 9 hours, there is an optimum growth of the cells. And after these hours of inoculation, they don't observe a significant change. We can observe in this image. So they use the confocal microscopy, allows the assessment of non-destructive bacterial growth in a microfluidic device, which promotes the use of microfluidic device in microbiology. Something important, we have the same in this graphic when we observe that the optimum time of growing cell is in 9 hours. So in conclusion, the confocal microscopy allows the assessment and non-destructive bacterial growth in a microfluidic device, which promotes the use of microfluidic device and microbiology. Thank you.